Hey, what's up, people? I've got this Nintendo DSiXL sitting here that was previously water damaged, and this is one that I've had around for about maybe 10, if not more than 10 years now. It's been kind of kicking around, but at the time when I got this, that it was water damaged, I had neither of the tools nor the experience to try to repair it. And I mean, I have some of the tools now. I don't know if I can say much about the experience, but we're gonna give it a shot today and see if we can actually get it working again. And it actually did work. The only thing that was wrong with it was that it had no sound output. But looking at it now, I can see that it's got potentially like a broken touch panel in there. I'm not entirely sure yet. It is for sure scratched on the outside right there, but it's really hard to get on camera here because of the glare. But inside, I can kind of see like what look like some cracks. So that looks like it's going to need to be replaced. And I actually pulled this out recently. Well, actually, not recently. It's been a few months now. It's just kind of been sitting here off to the one of the corners of my workbench, and it's just kind of like staring at me sadly while I work on other stuff. And this thing's just kind of been on the back burner. So I just feel like it's been sitting there and kind of like looking at me like, "Excuse me, sir, will I get my turn soon?" Yes, yes. We'll try to take care of it today and see if we can do anything about it. So, since I said that the touch panel possibly needs replacement, I have already ordered a replacement here. So that's a brand new one. And also, the battery itself has kind of got some corrosion in there. And because it's been sitting around, like I said, for possibly more than 10 years, I decided to just get a replacement battery. And this is actually a generic replacement that claims to be a 2000 milliamp hour, whereas the original says that it's a 1050 milliamp hours. So technically, it's almost double. I don't know how accurate that amount actually is. It could be totally the same as this. I have no idea. But brand new batteries, so at least we know we're not going to have any issues regarding that. So let's go ahead and open this up. I'm going to have to remove the screws. I believe there's some screws underneath the little feet here. Yeah, okay. So I'm just going to remove all the screws and get the at least the bottom off for now. All right, I think I'm going to need some sort of a little plastic spudger or something to go around. There it goes. So that, I don't remember how exactly it's all in here. Oh yeah, there's another screw right there. Whoops, almost broke it. Now this should open up. There it goes. And I have 1, 2, I think. Yeah, 2 ribbons. Okay, there we go. So that one was for the volume buttons, and the other one is for the SD card slot. I don't know if there's any issues going on with those. I don't know how much water this thing took in exactly, but I do remember it was water damaged somewhere. I'm just going to have to find it again. Okay, so I'll have to finish taking off the rest of these connectors and pull the main board out. And there's another ribbon on the opposite side. Right there. So this goes to the top LCD. There we go. Okay, now let's see if I can find where the issue was. Oh, okay. I think it's going to be that area right there. And that makes sense because it's right here where the audio jack is. Well, we certainly do have quite a bit of corrosion in there. Some of these contacts there don't look like they ever actually had anything on them. Like, for example, these right there. That looks, you can see where it's got some corrosion on it. I don't know if that looks like a capacitor. Yeah, C108. So that would maybe be okay if we clean it up. See corrosion right there around the legs of this little device. I have no idea what that is. That one right there looks pretty bad. This capacitor here looks like it's lost part of its end right there where it's supposed to have like metal. That looks pretty crappy right there. A lot of these look like capacitors. The only problem is I don't know what value they are. There was nothing there. Another capacitor. Up here, it looks like this is supposed to be a resistor, but these are the kind that don't have any labels on them, so I don't know what the heck they're supposed to be. So thankfully, it doesn't look like anything on this side of the board has been affected, except for like a little bit of corrosion right there on those contacts of this connector. So this side looks pretty good. So what I think I'm going to do here is I'm just going to remove these components like one at a time, the ones that look bad. and I'm going to try to measure them outside of circuit and see if I can figure out what they are. Thankfully, there's not that many, so it looks like maybe those two resistors right there. So that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I think that was it. So yeah, I'm just going to remove one at a time, try to measure it, and keep a list of all the components that may need replacement. All right, so first we flux, then we plux. Okay, I think that was the last of it. So took pretty much almost everything off of this area with the exception of this device right here that says EM4. I think that's just going to be like a little choke, and that one looks like it's fine, so I just left that on the board. None of these other ones look bad. That one looks like it's got a little bit of a spot right there, but it looks like it's just superficial, so as long as I'm getting continuity from one side to the other on that one, it should be fine. And it looks like we possibly may have lost some vias around here. I can't tell yet if that's gone or not, or if it just looks like it is. And so, yeah, this is going to require some cleaning. So I'm just going to go through it with a cotton swab and some IPA. Clean this off, and then I'm going to have to go through and like re-tin a bunch of these pads. And like I said, some of these were not used, but might as well just take care of it while we're in here. So, yeah, let's do that now. Okay, just swab and clean. I'm trying to avoid getting anything on these buttons here so I don't get like seepage inside of them. So I'm trying to keep everything just contained to this little general area over here. Okay, so I think that should do it for an initial cleaning. Now I'm going to go through, apply flux again, and try to re-tin all these pads. All right, so I've applied flux again. And now to add some fresh solder to these. Oh, good. That one doesn't look like it's gone, so it should be fine. Ah, these pads are gone. All right, that's going to need some work. Those are okay. These are gone. The one on the left might not be. Okay, that one's still there. And that one's a goner, and that was a via, too. Darn. All right, gonna have to try to fix that. That pad is gone. This one's gone. These look like they're gone. All right, so this is the damage we're looking at. We're missing a pad right there, but luckily that just goes to that trace right there, so that would be easy to touch up somehow. This one here, also, this pad that's missing there just goes to that trace. This one goes to that trace, so that should be okay. This one here goes to that via, so that's going to be a bit of a hassle to deal with, but should be doable. These look fine. I think some of these were the ones that were not used. Was that one used? I think this one was not used, but that one we can probably ignore then. That one's missing, but it just goes right there, so that's okay. This one goes to that via right there, and that's all intact. So that's okay. These look fine. These two are missing. That one also easily accessible. There was nothing up here. This one I didn't even pull off because it looks fine. That looks okay. This one looks fine. This was the little IC that was sitting here. The pads for that all look good. Not too bad. Not too terrible. It looks like it's we can work with this. And because I didn't want to deal with taking off one component at a time and checking it and then having to go back and take another component off, I just took off all the components one at a time. And then I used a little piece of tape and stuck them down right here, and I labeled which position they came out of. This one here there was nothing there, so I didn't count that one. But so as you can see, so these are super tiny. So I'll see what I can measure out of these, and maybe I'll see if I can find replacements. I'm probably gonna have to order a lot of this stuff. This is gonna be stuff that I doubt I have anywhere on hand. This IC right there, the U17. I think that one looked okay, but I'm going to double check it. Make sure that none of the legs are like corroded through or anything like that. Although none of them came off when I pulled it off the board, so I think it might be okay. And so yeah, gonna check one of each of these one at a time, size them up and see what sort of package size they are. Even though on some of these, as we saw on the board there, I could probably go a little bit bigger. than the actual part was, especially the ones where I need to actually like bridge between two areas where the pad for it like came off the board. And just so we can see how small these components actually are, this is R10, and I have this little component reference guide. And as we can see here, the smallest package on this is 0603, and it's even slightly bigger than the components we're actually dealing with. But this is the smallest size we have, and because I said that I might need to size up the components a little bit bigger than they are, so I can get some of those gaps to bridge where the pads are missing, I think I might go with the 0603 components when I can identify what they are. All right, so I've gone through the list and I've tried to measure everything as best as I could. Unfortunately, this resistor 10 right here, I could not get a reading out of that, so I have no idea what it is. But I'm hoping that maybe just looking at the board and its location and maybe seeing how it's wired, that could give us like some context clues about, what it could be or what its value range might be. Or I'll see if I can find any information online, maybe like find an exact value or something. I haven't looked yet, so I'm not entirely sure. These two other resistors, they both measured a pretty solid 100 ohms. So I'm pretty confident about those, but even though they measured good, I'm still going to replace them just because of the condition they were in. I don't want them to like further deteriorate and, go bad at some point in the future. Let's turn this off because it's starting to beep at me. The capacitors, this one here measured about 100 nanofarads, so pretty confident about that one. This one here measured close to 100 nanofarad, but it also had some corrosion on it. So I'm pretty sure that it probably is 100 nanofarad, but I put a question mark there just because I wasn't entirely sure until I measured some of the other ones. And I'm thinking that all of these tiny ones, the ones that are smaller than the 0603 size, I think they're all 100 nanofarad, even though some of them I could not measure. But the ones that I could measure all gave me a 100 nanofarad reading. So I think it may be safe to replace these with 100 nanofarads. And there was this 1206 size device here, the capacitor. That one measured pretty close to 47 microfarads, so I'm pretty certain that's what that one's going to be. This other one, tiny one here, also measured about 85 nanofarad, but since it had the corrosion, I'm probably pretty confident that it is going to be a 100 nanofarad capacitor also. This resistor right here, it measured a pretty consistent 0.124 ohms. So I'm not entirely sure if this is supposed to be like a really low value resistor or if it's just a jumper. I'm going to have to go back and look at the board and see where it's connected and see if maybe that gives us a clue as to what it should be. And if it is practically just a jumper, not entirely sure, but even though I tried to like clean it off a little bit, it still gave me a reading of about that much. So I think that might be correct. Not that this exact value is correct, but that it's a extremely low resistance resistor. This one here, this 0805 size, the capacitor, I could not get a reading out of that one. It's just too gone. There's like nowhere to make contact on the end. So it's this one's a mystery as well. Got another 100 nanofarad capacitor there, 100 nanofarad capacitor. And the little U17, that little SOT 23.6 device, actually, it's smaller than that. It's like a smaller package. But anyways, I took a look at it under magnification, and it looks like all of the legs are intact. Some of the legs had like a little bit of goopy stuff on the outside, but once I like scratched it off, it revealed the copper underneath. So I think I should be able to tin those and reattach that IC. I'm not entirely sure what it is, but it looks pretty good. So I said that one's probably good. Now, the unfortunate thing is that, like I said, I'm not going to have a bunch of these tiny capacitors on hand. So I am going to have to end up like ordering some components. In the meantime, while I'm waiting for like this stuff to arrive, I'm just going to try to do as much as I can on the rest of the device itself. So we are going to have to replace that touch panel, as I mentioned. But what I'm going to do first is I'm just going to completely, oops, I didn't mean to do that, but all right, so that's out. So I'm just going to strip all the rest of the components off the casing and clean everything, check to make sure that there's nothing else that may have like corrosion on it. And after that, I can reassemble it all. And once I have the components for the board, then we'll continue with the board repair. And hopefully everything goes well and it works. I'm going to have to check in here to see if there's any corrosion on this connector there for the cartridge. And I may also remove this headphone jack. Yeah, looks like everything's on this board at least was pretty much just contained to that one little area. So I've got everything off the bottom of the bottom half of the case here, and looks like there's a tiny little bit of corrosion on the end of that one LED right there, but it doesn't look like it's affecting anything. So I'm just going to probably just clean it off and make sure that there's continuity from the end of that LED to that via and to the opposite side, which looks like it's just ground. So as long as the other side is grounded, I think that one should be fine. Nothing else that's on here, so everything else looks good. So I ended up removing the headphone jack from the board, and that was just to make sure that there wasn't like any nefarious activity going on underneath it. And there actually does appear to be one via that appears to have some issues, so we'll take a closer look at that in a minute. I want to make sure that there is continuity going from this side of the board over to the other side of the board, and that way we can be sure that there's not going to be any issues in the future or anything like that. And I also want to make sure that I get that fixed before I put the headphone jack back on, because then having it back on just means I'd have to probably pull it back off if it turns out that there is something wrong with that via. And now, in a similar manner that the Go-Go's claim that they've got the beat, or Arby's claims that they've got the meats, or that Electric Cowboy claims that they've got the moves, I'm claiming right here, right now, you heard it here first, I've got the parts. So I think I have everything that I should need to try to get this working again. I mean, at least audio-wise, because I'm pretty sure that was the only issue. I went through and I tried to like analyze everything as best as I could to see what the extent of the damage was and what I would need to do. And actually, I also revisited all the components that I pulled off the board to try to make sure that I could actually maybe or potentially get like a reading from some of the parts that I didn't have a reading for before. And for this tiny resistor that was in the R10 position, I actually got it to measure at about 75K, and it was pretty consistent. So I think that's what we actually need there. And that's what I ordered. I also realized that some of the component designations are actually kind of like mislabeled, like this was not CL28, this was actually C32. And down at the bottom where we have this 0805 capacitor that I couldn't measure at first, I actually was able to measure it. Where I was able to measure it, I got about 8.5 microfarad, but that's kind of an odd value, and it seems that it's for power, so I'm thinking that it's probably supposed to be 10 microfarad, so that's what I ordered. Now, the way that I measured this resistor that I couldn't previously measure and the capacitors is I actually got some needles, and these are just kind of like little like tailoring needles, and I actually attached them to the ends of these test leads that I've made. So I was able to do that, and because they are really, really sharp, I had to keep these attached with the tape or on a piece of tape. And with the help of the microscope, I went through and I was like, trying to like scrape off little bits of material where I could to try to get it to make contact. And that's how I was able to figure out some of those components. I'll see if I can like give you an example in a bit here. I'd have to like set it up again as to how I did it. But I'm fairly confident that the values I got are going to be fairly accurate because I could not find any information of any of this stuff otherwise. So to measure some of the components that I couldn't previously measure using my regular pointy test leads, this is what I did. So I took a piece of tape and I put it on upside down on like a piece of paper. And as you can see on the ends, I'm actually holding it down with another piece of tape. And this one's like sticky side towards the paper. So this tape is sticky, so I could stick the components to the surface of it. On the other end, I'm also holding down that piece of tape with another piece of tape. And so this helps me secure the components instead of trying to hold them with tweezers and trying to test them at the same time. This way I can actually kind of like, like put the leads on there and they don't move around very much because the tape holds them down. And if we zoom in on them, we can see that on the capacitor, we only have like the one terminal on the right side. But on the left side, we just have that little tiny piece right there that's like on the surface. So it's not really making contact with the capacitive material. But if I kind of tilt it over a bit, we can see on the end that there is a little bit of copper, but that wasn't previously visible. So what I did is after I stuck this down to the tape and I took the needles that I mentioned earlier, I attached one to like say this end of the capacitor. And on the other end, I just kind of scratched the surface until I was able to get down to that copper. So I'm going to have to hold this with the tweezers so we can actually see what's going on. But basically, I just started scratching at the surface until it started exposing the copper, because underneath this crusty looking stuff, we can get to the copper. But once I had enough copper exposed, then I could check it with my multimeter. So just set this down so that I can make good contact with both sides. And so now if I take the two needles and I touch them to that capacitor, you can see that I'm getting about almost 8.7 microfarad, but it keeps trying to shift. Well, I'm really struggling to get a reading out of this capacitor again, but for like a brief second, I actually got that 8 point, what was it? Like about 8.5, 8.7 or so microfarads. The resistor was a little bit easier due to the fact that it can just lay flat like this, so I can just poke it in from the top. And where the resistive material is, I kind of went in a little bit, and I tried to scrape off some of that material that covers the actual resistive layer. And as we can see, right about there, I'm getting about 63K, but that's probably because I'm a little too far in. We want to be like as far out as possible to get the best total resistance of this resistor. So now that I'm measuring it again, it's down in like the high 60s. I don't know why I'm getting such a discrepancy now. Yeah, when I originally measured this, I was getting about 75. So yeah, I'm not entirely sure what the exact value is actually supposed to be. And so some of these are kind of assumptions, but hopefully everything works out okay. And I also took a picture of that area of the board where we're going to be doing all the work, and blew it up by a significant amount. As you can see, there's that tiny little IC that was in that position. And the size of that device is actually a SC88 or a SOT3 63. So it's a little bit smaller than a SOT23.6. But this way, I can actually go through and like visually see where stuff's supposed to go. And that way I know that this was supposed to be a 100 nanofarad capacitor, the 10 microfarad capacitors. And there was these two where there was solder points for resistors, or I think actually they say CL, so I'm guessing there's supposed to be some sort of capacitor. But when I went back and reviewed the footage, I noticed that they're actually basically a straight link all the way from like both ends of like these pads or these traces. So I'm going to have to solder like a piece of wire between like one side to the other on both sides. So like here as well. So I'm guessing that must have been for like some sort of option that this didn't include. So they were just straight through. This one did not contain a component, so I can just ignore doing anything with that pad. I'm going to have to fix up like a few of the pads where they are missing. So being able to see this like all blown up should facilitate the placement of all the components. Another thing I'm going to use to try to fix some of these missing pads is these Wiley branded, it's a little pack of copper, basically like little traces and dots for like BGA repair and for, some contacts. These things are like super tiny. And now I can't get this thing to focus. I'm struggling here. So anyways, there's a different variety of the pads that we can use to try to replace some of the missing stuff. There's little round ones. There's some small rectangular ones. I'll see what I can use. Hopefully this will work. I've had these sitting around for a while. I think I bought these on eBay. There's other packs that come with like different shapes and sizes as well. So, but this is what I happen to have. And another thing I'm going to try to use for repairing some of those bad traces and pads is this super quick drying UV solder mask that I just recently found out about. So it's similar to the other stuff I've used before, but it's supposed to be like really fast at setting. So we'll give it a shot and see how it actually does. So one of the first things we'll do is we'll verify that this via is okay and that there's continuity going from this side of the board all the way to that pad. And there you can kind of see what I mean about it looking kind of questionable. And I'm referring to that one. And so it feels pretty solid in there. So maybe the actual wall was not affected. And on the opposite side, that via goes to one of these inductors, I believe they are. There we go. I've got one probe on the inductor. I'm putting the other one on that pad. And we've got continuity. It looks kind of high, but I mean, I got some like resistance between the probes, so it's totally fine. There doesn't appear to be any issues with that via. It just looks kind of crusty. I'll see if I can at least like maybe clean it up a little bit, but other than that, it seems okay. There's another via up a little bit higher that looks like it's got something going on there, but let's see. Let's wipe it off. Might be okay. Just dry it up a little bit. Ooh, this one definitely looks like it might be missing some material. Yeah, that's definitely gone. That's going to need some bridging. All right, well, at least we identified one issue. I don't think there was any others that looked questionable. Since there don't seem to be any other issues underneath where the headphone jack's supposed to go, I'm actually going to just tack it in with one of the mounting tabs that it's got on the front side of it. Just like that, just hold it in place, because that actually helps kind of like level out the board. You can see how the height of that is basically almost at the same height as the cartridge connector. So it just helps it so it like sits nice and flat. That should facilitate me working on it. And I'm just cleaning the entirety of the surface where I'm going to be working, just to make sure that there's no like residue that's going to prevent the UV solder mask from sticking. So let's compare some of these small pads to some of these replacements that I've got. And it's smaller for sure. Like I was thinking maybe some of these rectangular ones might work. Maybe I will go with the bigger round ones over on the other side, and I can have that fill in like most of the area there, or maybe even these might work. That way I can have a little bit of room around it so that some of the UV solder mask can fill in. I'm going to use a technique that I saw on some videos of where these were being used, so I think that might work. So first of all, I want to clean up the ends of where some of those the little replacement pads are going to bond to, so I'm going to solder that to like that one. I forgot that some didn't have components. Like this one I didn't have to worry about. This one I didn't have to worry about. And we'll just clean off all the debris. Whew, these things are tiny. And it broke. I got one. I forgot we want to have a little bit of the UV solder paste on there first, and I think that's a bit too much. This is really tiny stuff after all. All right, we're going to try to get this back over, and it's fine if it gets covered up with the mask. I do want to make sure that that little tail I had on the end is in the direction of the copper trace. And let's give it some UV light. Seems to have somewhat hardened. Well, it's not wiping off, so far that's good. Do need to re-expose that pad. And I'm going to remove the top off of that one. And we need to expose some of this copper. And a part of that broke. Great. And more of it broke. Great. Well, the good thing is that it looks like that pad's going to be a pretty solid anchor point for the capacitor or the resistor that's actually going to go in this area. So basically what I can do is I can just bridge these two together once I have the resistor back in place. And that's one of the resistors that's going to go, or this is the resistor that's going to go in that position. These things are absolutely diminutive. They're tiny. All right, got a bit of flux there. I'm going to see if I can get this one to stick to this side first, because there still has a bit of solder on that pad. I didn't completely remove it all. So once I get it tacked down, I will solder the other side in place. And I probably should have tinned that pad first, but I kind of forgot about it. So we'll just tin it like this. And yeah, that's not going to bridge. So I'm going to... Oh, it did. No, I don't like that. I'm just going to have to put like a little piece of wire on there. All right, so I got that one jumped at the wire, which is not exactly what I wanted to do, but I mean, this is my first time using these things, so I'm still kind of trying to get the hang of it. I mean, it's a little sloppy, not exactly my best work or what I would have wanted it to look like, but it'll do. Something I realized I forgot to do was clean off the excess solder from some of these pads that I'm going to have to reattach components to. So I'm just going to go through and do that real quick just to make it so that the components can sit nice and flat on the board. And then I'll continue with trying to repair some of these missing pads. I'm going to try to do it in a slightly different manner this time around. All right, so the other way I saw this done was tinning the pad where they're going to be soldering to first. And I already have my new little pad on the side right there, as you can see. So I'm going to apply some solder to that first. And then I can bring my new pad into its position. This one's actually closer right there to that, where it needs to be soldered. So this one's going to be better than the other one. And we're just going to tack it down. Then we can break off the extra. It should just snap off because, I mean, it's like super thin. And it's easier to get these from the round end first instead of trying to get the little trace that goes down. So we lift it up. Then we can grab it with some tweezers. I mean, they're still super tiny, but that's a lot easier that way. Oh, that one's a little blobby. Oh no, bro. Oh, that is hideous. Okay, let's try to fix it. I mean, that's a little better. It's not great. All right, so I did the same for this bigger one, except I used one of the slightly bigger pads. But like I said, I kind of wish that the little piece that sticks out from the little tail was a little bit longer. Or not longer, but wider, because it's really thin. So I'm hoping that the UV solder mask will definitely support it. I don't need one there, so I'm just going to ignore that one. I think that's about all the ones that I needed to add. Thankfully, it wasn't like a bunch of them. Oh, I do need one right there, though. And on this one, I'm going to have to try to get it to stick to that little bit of via that's still kind of poking out. Too much reflection. I can't tell if it's stuck or not. Added a little more flux. It looks like maybe it kind of like stuck around the rim, but I'm going to try to tack it down a little better. And the tail broke, and that does not, that's not attached. Failure. Okay, I think what I'm going to do, instead of trying to use one of these pre-made pads, is that I'm just going to slice like a tiny little bit of this material, because the thickness is actually pretty good, and try to make it so that it's about as long as I need for this area. And I'm just going to stick that down, because these leads that are coming off of the pads, they're just way too thin. I mean, they're good for like, really like fine work. But for this, I need something a little bit bigger. So I'm just going to try to use the edge of a blade as a guide. This is a dull blade, as you can tell. It's got a bunch of like burrs and stuff on it. Could have been a little wider on the end that's going to go to the actual component, but should be fine otherwise. All right, let's make it stick. And I don't like these tweezers. They're driving me nuts. They're not pointy enough at the end. Okay, that feels like it's stuck down. It's not moving. I'm going to try to carefully trim the little bit extra off the end. There we go. I think that's going to do it. All right, so that should hopefully do it for that portion of the work. Now I'm going to try to cover these up to protect them, so hopefully they don't come out. I forgot to hit the unpause button to keep recording, but I got these all fixed in place. The solder mask cured pretty fast, it looks like, and oh, that one's still squishy. Never mind. Well, these I'm going to have to scrape off some of the material from the top to expose the, and there's still stuff underneath. All right, well, I'm just going to scrape it off a bit, and then I'll try to harden that up a bit. And you can tell that that's loose underneath. This is so frustrating. Well, one thing I can tell you is this stuff is actually pretty hard now that it's cured. And I'm not going to expose too much of this one. I'm just going to do about that much. That should be enough for that. What is it? A capacitor to attach to. Okay, I think that one's pretty affixed. I don't think it's going to move anymore. Ah, it's still moving. Dang it. I'm going to try to put a little bit more around it now that I've kind of exposed it a little bit. All right, I think that's as good as that's going to get. I still want to fix this via, although it looks like maybe there is material there. It's just that it's kind of dirty, so it's hard to see, especially around this edge. Although I don't know if that's enough to make good contact. It doesn't really look like it will. Well, I thought I was going to have to drill it out. I got some really tiny drill bits that are able to like go through that via. But since I'm able to make it all the way across, I'll be able to just kind of use like a little bit of wire to link from this side to the other side, and that should be totally fine. And I completely forgot that it wasn't this one that I was concerned with at first. I think it was this one, although I think I'll have to review the footage to make sure. I am going to need a smaller drill bit for that, but I do have like this absolutely microscopic one. This even looks like it's a little too small, actually. I have a slightly bigger one. So that one there should do. Let's see if I can make it to the other side with this one. I'm just kind of going back and forth because I can't really make it go in a circle here. I don't want to use any power tools or anything. I'm going to break this bit. It's so tiny. There we go. Made it through. Ah, there it is. It's that pad right there. Perfect. And that just goes straight into that IC. And for the wire, I took this really thin strand of wire that I just kind of doubled over and twisted together. That looks like it should be enough to go into that via. So I'm going to probably have to trim off the end. I don't know if where it's folded. No, where it's folded, it's not going to want to go through. So I'm just going to trim it back a little bit. All right, let's try to get that through. All right, I think that made it. Yeah, there we go. We got it, except that I realized I should have cleaned this side up a bit first. So hopefully I don't cut it. I'm going to try to be gentle. And I'm going to do the same thing to this one, basically, just to make sure that there are no issues, even though it doesn't appear that there will be. Just to be on the safe side, I don't want to have to come back and redo this all. So I'm going to have to make sure that it solders to this side and to this side. Okay, so both of these on this side are done. And this one, since both of these were links, and it looks like it's part of a power trace, I just bridged everything together from here to that side and then over to this side. So that should be done. I just got to solder these on the opposite side, and then those two should be done. And I should be able to start repopulating all the missing components. All right, there we go. At this point, I do believe we're ready to repopulate, so I'm going to start with the 100 nanofarad capacitors, which I believe there was at least 7 of, and then we'll move on to the larger capacitors. There's the 2 resistors over in this area, and then there's still the IC. So I'm just going to start by putting a little dab of flux everywhere we need a small capacitor. And I'm just going to drop 7 of these little bad boys onto the board so I can easily grab them. If they would fall out. Got 1, 2 that kind of slid out, 3, 4, 5, 6, and I scored this sheet so that I could just tear it off easily. There we go. 6 and 7. Wait. Oh, over here. Gonna try to hit this one on the side where there's still a bit of solder left on that pad. Get it to stick down. Okay, I think that was the last one. So let's hit the 100 ohm resistors next. Okay, and I got the 2 resistors in place. I don't really like the positioning on this one, but it's kind of hard to, it's going to be difficult to move it out of the way now. So as long as it's making contact, it's fine. And we've got that little 6-pin device. Just going to try to tack down at least one of the legs. Okay, I think that's fine. Just the last 2 capacitors, and we should be done. And the last one. Finally. And with all that done, I soldered the headphone jack back into place. And we're ready to give it a test run, except I got to put everything back together because I took it all completely apart so that I could clean like every little nook and cranny of the thing, because there was quite a bit of like caked on stuff there. It almost looked like maybe like food residue or something. So once I get it all put back together, we'll pop in a battery and we'll see what it does. I was in the middle of reassembling everything when I realized that there's still two things that we need to deal with. And that was the little bit of corrosion on the DPad board over by where the indicator LEDs are. There's also another via close to the battery terminals that looks pretty questionable, so I think I'm going to take care of that one as well. And then the other thing I still need to do is replace the touch panel on the bottom display. And you're probably going to be like, didn't you just recently take this apart? Like, how could you forget such things? Well, no, that's because I took everything apart about 4 months ago. Or it was about 4 months between the time when I finished taking everything apart and when I actually got around to ordering all the components and actually starting to do the repair on this thing. So, yeah, it's been a bit. I forgot some things. And at one point, I actually thought I misplaced some of the components and I couldn't find them. But turns out I just had left them in a little bag and I forgot to put it with the rest of the stuff. So I should have everything. I don't think I lost any parts. And here's the two vias up by the LEDs in question. There's this one that, I mean, it does look bad. But this also is part of a trace that goes down into this section, and there's another via there, and that looks like it's all part of a ground plane on the back of the board. So even if I didn't repair this one, I don't think it would be a big deal, but I think I'm going to take care of that one anyways. And then the other one is this one that goes to this LED, and since that's the only one that goes to that LED, this one's for sure is going to need to be fully conductive. So I am going to fix this one up, even though it doesn't look too bad on this side. On the opposite side, I'm not too sure. So just to be on the safe side, just to avoid any issues later, I will repair these two. And the other one is down by the battery terminals or the contacts. And as you can see, it looks pretty dark. So that one goes to a trace that goes over to this side of the board. And that just goes to the center pin of the battery contacts. And that's looks like it's for like, it says DET. So I'm guessing some sort of detection in the battery. Maybe it's just for like temperature sensing or something. So I'll just make sure I jump across from this side of the board to the other side of the board. I'm pretty sure this fuse is fine because, like I said, this thing would power up. It just had no audio. And I'm just going to repair all those the same way I did the vias on the main board. As far as the touch panel goes, I do need to remove this like red bezel around the display. It's actually like over the touch panel and it's stuck on like really hard. So I don't know if I'm going to be able to make this stick again. Unfortunately, since I forgot about it, I didn't buy like any double-sided tape that I could use for this. It is separating. I'll probably use like a plastic razor or something to try to like get it all off the board. This does appear to have some double-sided adhesive on the side that actually goes up against the LCD itself. So this one should adhere by itself. I'm not too sure about the red one, but if this doesn't stick well or I still need to do something about it, I'll just get some adhesive later and then I can, easily take care of that. That's not a big deal. So once I remove this red border, I can pop that drop it into the case and that'll align it. And then I can drop in the touch panel. And because it's like basically a shape for it, it'll align that. And then I can put the LCD on top. Everything should be well aligned and I don't have to be sitting here trying to like put everything together and trying to make sure that it aligns properly. Like the case can do it all for us pretty much. All right, so this board is done. I don't think I need to worry about any of those anymore. It's not ideal, but it came off mostly okay. So I'm just going to drop that into the case. Then I can drop this into the case. I still got the screen or the protector on the back of this one, so if I touch it, I'm not going to leave like a bunch of smudges on the glass or anything. I just got to finish removing the rest of this panel off of the LCD. I'm trying to keep it at an upward angle like that so that I don't accidentally touch the actual LCD panel. There we go, detached. Still got some adhesive in there. And there's a little bit of debris and stuff that landed on the LCD, so I'll try to clean off some of that without touching it. A little piece of tape will do wonders for this. I don't see any other dust or nothing noticeable, so I think that's going to be good. I'm going to remove the protector off of the main panel, or the touch panel. And it still has the liner for the adhesive on it. So then I got to remove this. I'm sure there's probably a better way to do this, but this is all I could come up with at the moment. And I almost did it backwards. Okay, I think that's going to do it. Not bad. This is on the outside. It's not on the glass itself because I touched it on this side. But other than a little bit of stuff around the edges, it's really not that bad. Definitely better than the old one. All right, this should be good enough to test, I think. Let's pop in the new battery. And I've got a power supply. I don't know what the state of the battery is, so I'm just going to go ahead and plug in the power supply. Let's see if the LEDs light up. So, saw a red one there for a sec. And that was it. Is it not charging? Alrighty. Well, let's try to turn it on. Let's see. So that would be the one that indicates that it's plugged in. So let's see if it turns on. Well, okay, I was a little worried about the top display because when I was reassembling the top section, I creased the ribbon cable a little bit, and I thought maybe I tore it, but it doesn't look like I did. So, touch panel is working. Sweet. And that's going to be blurred. It's got the original user picture on there. So, it appears to be working fine. I've got audio coming out of both speakers, it sounds like. There, I took a new picture so we don't have to blur the top. So, yeah, it seems to be working. Both sides of the speakers are working. Hear that? That's the right side. And that's the left side. Hopefully it comes through because I'm not entirely sure if it is. I'm going to have to test the headphone jack. All right, I put some headphones on. I'm just going to plug this in. Yep, both channels are working. So, yeah, that got it going. So, it was that was it. It was just a bit of corrosion, replacing the components. And it seems that the components I chose were adequate, at least, if not the exact ones that it needed. The microphone seems to be working. You can see that it increases there when I talk or if I, like, scratch at the surface. So, it's audio-wise, it seems that everything is functioning properly. I thought maybe there was something wrong with the battery, but if I disconnect the power supply, it looks like it's full, so maybe that's why it doesn't light up, although I'm not too familiar with the DSi. So if I plug the power supply back in, it goes back to flashing. So I guess I can let it sit for a while and let the battery drain, or maybe try to play something for a while and see if it drops at all, and then maybe if I plug in the power supply, I can see it charging. Okay, I let it run for a while until the battery died, and I was able to test it out with this Yoshi's Island DS cartridge, and so I can verify that the game cartridge is actually working totally fine, so that's no issue. I also stuck an SD card into the SD card slot, and it detected it just fine, so that doesn't appear to be an issue. Now, when I tried to plug in the charger, it does the same thing that it was doing, where it flashes that LED. And if I try to turn it on, it will come on, but if that battery drops below a certain point, it just shuts back off, so it's like the battery's completely dead. So it doesn't appear to be charging the battery, unfortunately, so it seems that we've still got at least that issue to try to resolve. And just to see if there was any known issues regarding battery charging on these, I decided to just kind of look it up. And I came across an article on iFixit or not an article, but like a post where somebody asked, basically the same exact issue I'm having. And they mentioned something about there being, or that fuse that we saw on the DPad board that I just kind of ignored. They said that sometimes that can go bad and then that can cause the issue that we're having. So I'm going to pull that board back out. We'll check that fuse and see if that fuse is bad or not. There's another fuse over by the charging port, but I mean, I'm taking that one's fine due to the fact that it shows that it's at least like plugged in. So this is the fuse that's connected directly into the power input. So if we check this, and I've already zeroed out my multimeter so that we get a good nice zero there on the resistance. So this one is fine because we're getting continuity all the way from the power connector to this EMI filter. So that's fine. And this is the fuse on the DPad board, and I would think this one would be okay due to the fact that it's powering up, unless it's only used for like charging or something, and then there's another trace that goes over to the other connector to actually power up the system. I'm not entirely sure. So, well, let's see what it says. So we're gonna connect between this point, and I think this trace appears to go into right there, so that would make sense. Let's see what it says. Yeah, no, that fuse is fine, so it's not the fuses. The only other thing I can think of, other than there being something wrong with the main board still, is that there could be something up with the battery, and I think that would be the easiest thing to check, because I don't remember seeing anything else corroded inside of the actual system. So I took apart the old battery, and this is the little board that interfaces to the contacts on this board. Maybe if I take a known good cell and I hook it up to these 2 points, and then I connect it to this board, I can trick it into thinking that there's a battery installed. I did take a look really close up at this board where the corrosion was, and it looks like it was only on the surface of the contacts. So I cleaned all that off. It doesn't look like anything else was affected. And unfortunately, we can't see all the components on this side of the board because it's all coated in like an epoxy blob. So I'll try that. Let's see if that actually does anything. If that works, then that means that there's something up with this battery pack, and it's maybe something with the board there. It's like kind of I mean, like I said, it was a knockoff, so it could be that it's just crap from the get-go. It hasn't been sitting around for very long because I had bought this stuff like really shortly before I actually took it apart. And like I said, it's only been about like 4 months. I really don't think that's enough time for like a brand new battery pack like this to go dead. Let's at least try tricking it first and seeing what that does. Okay, so I got a battery connected with alligator clips over to the little interface board. And if we check the voltage at the terminals or the contacts, we should have about 4 volts because this battery is like almost fully charged. It's not exactly fully charged. So that works. So now I'm going to carefully try to touch this to those contacts while I plug in the power supply, and we'll see what those LEDs do. Okay, so I've got good contact on that. Let's see. Nope, it did the same thing. I am able to power it up, though, without the power supply, so that means that this is providing power to it. Yeah, it still won't charge, though. I did an inspection of the board over on this side where all the power stuff is, and I marked all the vias that potentially look problematic or that have at least like visible evidence of a little bit of corrosion on them, just so I can inspect them better under the microscope. And for the most part, most of them look like they're fine. It looks like it's mostly external, and the internal material, all the plating looks okay. However, there is one of particular interest, and that's this one. So this is a fairly thick trace, as you can see. There's 2 vias over on this end, and then there's one large via over on this end. And if we flip it over, that via connects this IC, the 2 pins that are on this side. They go through those 2 vias, and it comes over to this side. But as we can see, there's nothing up on the surface. So there's an internal trace that goes from this via over to who knows where. I have no idea. I could not find like where it actually connects to. But if we zoom in on that and we light it up from underneath, we can see that it looks like all of the plating on the inside has been completely eaten away. But as we can see along the walls, there's what appears to be like some copper traces. So I have a feeling that's the actual trace that's running internally inside the board. I tried to see if I could stick like a piece of wire in there and hook it up to my multimeter to see if I could trace it out, but I could not find where exactly it goes to. But due to the fact that it's a fairly thick trace, it's pretty evident that it carries power. So it could be that this is has something to do with why the battery is not charging. So if we could get this connected to the other side, maybe we can get the charging working again. So I'm going to carefully grind away at it and see if I can expose the copper that's inside of the board. There it is. We're getting to it. I'm trying to be really gentle, and so I don't grind away like too much material. And this is the opposite side of where we need to solder it to. Yeah, you can see that there's like absolutely no plating in there. Okay, so I took 3 strands of really thin wire and I doubled them over so that I have a total of 6 strands twisted together. And it looks really thick under the microscope, but this stuff is really, really thin. So I'm going to trim this end off, and then I'll try to get the wire to go through that via. We're going to fasten one end on the bottom side of the board where the big thick trace is. Going to fold it over and secure it with some tape. And then on the opposite side, I'm going to like try to cut it like really flush with the board. And then I'm going to fill in that hole with a little bit of flux. And then I've got the smallest tip that I got from my soldering iron. I'm going to try to tap it in there and see if I can get any solder to stick to the wire and to the via. And hopefully that'll work. So here we go, trying to get those strands of wires to go inside of the via. And I'm kind of at a bad angle here. There we go. So that's through. And on the large trace side, I'm just going to secure it with a piece of Kapton tape, just to hold it in place so it's not shifting around on me while I'm trying to work on the other side. Make sure that it's as flat as possible. It's like I could have even used more wires than just the 6. Actually, it looks like I might be able to double it over at least once more, and then that way I can fill up that hole a little better. Okay, there we go. So that fills in a little bit better. And you may be wondering why I'm going with stranded wire versus going with like a little solid piece of a cut like resistor lead or something like that. Well, that's because I want solder to wick into the wire itself. I don't want it to just be on like the surface. That way, I think I can get a little bit more surface area and be able to maybe cover up inside a little bit better. Maybe I can actually like extend some of the strands like outwards so that they make better contact with that copper inside. So I'm going to try to cut it as flush as I can to the board because I don't want it to like solder to the outside. And look how massive these side cutters look underneath this much magnification. So try to pull on the end and snip. And there we go. Now let's see how much I can get these to kind of expand inside of that hole. Ah, there we go. See, that's kind of what I want. So far this is working out pretty good. That looks pretty good. And I just realized I completely forgot to hit record during the entire soldering process. But I just filled it in with flux, and then I used the thinnest solder that I had, along with the smallest soldering iron, the tip that I have for this soldering iron. And I tried to fill it in there as best as I could, and I think it soldered to the copper that was around it. So hopefully that's making good contact in there. On the opposite side, we're just going to tack this down, put some flux on there. Get that to adhere to that trace. I can trim off the excess, but before I do that, I'll see if I can figure out where exactly this trace goes over in the charging section of the board. Well, awesome news. So now if we touch that those 2 pads on the IC, we touch to there. Obviously, we have continuity because that's connected to that big trace, but also, and we touch over on this side of this IC, it was one of these pins. We now have continuity to this third one from up from this side. So I don't know if that also goes to like one of these devices. I can't quite tell, but oh, there we go. It goes to that one there for sure. So it looks like we now have current flow from at least this point over to where it should be over on this side. So hopefully that gets this thing working again. And since that seems to be working okay, I'm just going to trim off the excess wires that I left. There we go. Okay, I really don't think I need to have the entire thing assembled just to, or I mean at least like the LCDs or anything connected just to be able to test the charging circuit. So I'm going to hold the battery to the contacts on this board and I'll plug in the power supply. And if this is working, we should see the LED light up and remain on. So And oh, power supply's not plugged in. Duh. All right, take 2, and let's get rid of the multimeter up in the corner. Always forget to do that. Constantly leaving it up on there. So, okay, got the battery positioned. That should be it. Bring this back in, and I'm plugging it in now. Hey, it's blinking. I'm not sure if that's a good thing, but it's definitely a change. And I just realized I had the battery upside down in relation to how they're supposed to be on the contacts on this side. So it's supposed to be like this, and I had it upside down. Hopefully I didn't damage anything. I don't think so. It looks like maybe the circuitry can detect when there's something wrong with the battery, even though under normal circumstances you wouldn't be able to plug it in upside down. But let's see if flipping it over does it. So plugging the power supply back in, if it stays orange, then I think we're good. Nope, still blinking. So now I wonder if I blew that fuse then. Let's check the fuse. And it's open. Let's see. Yeah, no, dang it, I blew the fuse. Well, at least the fuse did its job. I had to do something, right? I don't know why I didn't think about this, but I could have just put the boards inside of the bottom of the case, and this will prevent us from putting in the battery backwards. And I soldered in a little tiny jumper across that a fuse, and so now we got to be double sure that we get the battery in the correct orientation, because we've got no more protection. We're just raw dogging the battery. So, I mean, I can only stick it in the right way into the case. So, I mean, we're sure that it's fine. So let's go ahead and plug the power supply in, and hopefully now we get a solid orange light. Still blinking, but it's blinking faster? Not sure if that's the same rate or not. Oh, the board wasn't pushed in all the way, so it wasn't making very good contact. But the battery's staying on now, or the LED is staying on now, so it's totally working. So that was it. That via was completely eaten through, and so there was no current flowing through from there to down into the charging circuitry. So I think now I can continue reassembling this thing, and unfortunately, that fuse is gone now, so I guess I can look for a replacement or just leave the jumper. But this board is easy enough to get out, so if I want to replace that fuse at some point, I can easily do so. All right, well, let's go ahead and reassemble it. After a few hours of sitting plugged into the charger, the LED finally turned off, and it just turned back on. That was weird. I didn't... Is it? No, it's not loose. Well, okay, so the thing is, it sat for a few hours on the charger, and the light was on, and then the light went out, but I actually did not get to working on it again after the light turned off, so it actually ended up sitting overnight on the charger, and I have not tried to power it on yet, so I guess we'll try to do that now, but that's kind of funny that as soon as I started recording, it turned back on. So let's try to power it up, and I mean, it should work. So yeah, that's working. The battery indicator in the corner still shows up red with the little plug flashing. So if I unplug it, I mean, it should remain on. No, but it did not. It shut off. Well, that's great. Okay, looks like something is loose or not making proper contact, because I can turn it on. And if I unplug it, it'll remain on. But if I bend it in this area, it shuts back off. And that's right where the battery is. So maybe it's got something to do with that board. I got to see if maybe I just didn't fasten it well enough or something. I don't think I put all the screws on it. Or did I? I'm not sure. I got to check and see if like maybe it's all connected properly. But one other thing I realized is that when I put all the components back on the board, I did mention that the resistor that was in this spot, which would be R127, I said that that was most likely a jumper, because that resistor doesn't measure like anything that would resemble like some sort of high resistance. So I'm pretty sure it's maybe like an option jumper or something. I forgot to populate that. I was just going to put like a little jumper wire across it. So I'm going to open this thing back up and see what's going on with this section. And then I'll probably go in and solder in a little jumper on those two sets of pads. And I don't know what difference it makes because like we saw, the audio is working, or as we heard, the audio is working. So no clue what that actually does, but I'll see if I notice any difference after jumping it. And if I still can't tell what the difference is, well, I seriously, I don't know what it's doing. I was about to flip this over to see what was on the other side of the board, and then I was like, oh yeah, this isn't the board. All right, so let's see if we can figure this thing out. All right, so hopefully that's the last time I have to deal with anything on the board like this, because it's a kind of a pain dealing with this little ribbon cable that goes up to the top LCD. So this time I didn't even bother to remove it. I just kind of tilted the board down and set it so that it's like resting on something so I don't accidentally tear it. So hopefully this is going to be good. I can put it back on now. Okay, so this seems to be a battery contact issue. It's nothing with the board or any of the wiring going to from like the main board to the DPad board or that little the two battery terminals on that small connector. Because if I just hold the battery up against the terminals, this stays on and it seems to be okay. I can like wiggle it around, can bend it, and it seems to make a good contact. But once I put the bottom case on and I put that battery back in, then that's when I start having issues. And it's like, as I bend it around, it kind of comes and goes, which is weird because we didn't really seem to have that problem earlier. So I'll just try cleaning all the contacts really well, and I'll see if maybe I can get these to maybe like spring out just a little bit more. I was trying to compare the original batteries contacts in this plastic case to see if maybe they'd sat like a little bit more closer to like the terminals compared to the new one, but I can't really tell much of a difference. So it seems that they're about the same. All right, well, that seems to have done it. I just kind of gave them a quick little cleaning, and then I just took the tweezers and I just kind of like slightly gave them a little push up, and it's not shutting off anymore. That LED's staying on. So I guess that was it, although I haven't tried powering it on again. Yeah, that's still fine. So now when we disconnect the power cable, it does stay on, and as we can see, it looks like the battery did charge, so it appears that the charging circuitry is working just fine now. As far as the audio goes, I honestly cannot tell a difference. It seems that the volume levels go up about the same amount. So as to let's see. The stereo still seems to be about the same, so I really have no idea what that jumper does. It doesn't seem to affect anything, at least nothing that I can tell. But, I mean, got to do something. Well, it's working, so that's totally okay with me. And one of the last things I'm going to do in here before I put the outer screws back on is I'm going to put a piece of Kapton tape on these two connectors, the two LCD connectors. I believe that those two were the ones that had a little white piece of tape over them. That's usually just done to prevent the latch from like somehow popping open and releasing that connector. Even though they kind of snap in like with a little bit of like positive force, so I really don't think that they can pop open by themselves, but let's just go ahead and put something on there just to be on the safe side. If I ever decide to open this up for any reason, it's going to be to replace the fuse on this board that I fried when I hooked up the battery backwards. So there should be no reason for me to open this thing back up otherwise, other than maybe to, oh yeah, I forgot. I also didn't have the adhesive for that little frame that goes around the touch panel. I mean, it's really not noticeable. You can't even tell that I did much in there. Oh, there's still a little bit of stuff in there. I guess I can try to clean that up. But other than that, I really don't have any reason to open the thing. Okay, and there we go. Got all the screws put back on. The 4 little rubber feet on the bottom, those went on pretty well. So this is all nice and secure now. It's not shutting off. The 4 screws that go on the top portion, I'm going to have to either replace like the little things themselves or maybe like put some new adhesive on them because they don't stick very well anymore. But I mean, other than that, everything seems to be working well. So I think we finally made it to the end. That charging issue was a bit tricky for sure, and that was a technique that I've never tried before. I mean, I've kind of seen some other people do similar things, but I've never done it myself, so I'm really glad that it actually worked out. So yeah, that's going to do it. We're going to leave this one here for now. Thank you all for watching. I will see you guys around the bench.